Okay, so our next topic on limits are limits involving infinity, and this is we can look at it a couple different ways. We can take a look at when x is approaching positive infinity or when x is approaching negative infinity. The other relationship that we can look at would be what happens when you have like a vertical asymptote and as x approaches like 1 or 2, it goes to a positive infinity or negative infinity. So we'll take a look at all those examples. So the limit as x approaches infinity, we generally have three different types of problems that we look at. The limit as x approaches infinity, and let's say that we have some sort of function like 2x squared minus 3 over x cubed plus 1. The rule in these types of problems is you want to divide by the highest power in the numerator. So what I'm going to do in this problem is I'm going to divide everything, all my different 4 pieces, by x cubed. So if I divide 2x squared by x cubed, I get 2 over x minus 3 over x cubed over 1 plus 1 over x cubed. Now in this particular problem, what happens is that as I let x go to infinity, 2 over this incredibly large number becomes 0. Minus 3 over that incredibly large number is also 0. The 1 stays, that 1's a constant, and then plus 1 over infinity, which is 0. So what happens here is this limit is equal to 0. So the idea behind these problems is that I want to take and I want to put everything to divide everything by the highest power in the denominator and then work out the situation from there. Let's look at our second example, and we're going to tie these to asymptotes in our next video, but let's look at our second example. Let's let x go to negative infinity, and let's say I tell you it's x to the 4th plus 1 over 2x squared minus 3. I have to divide by the highest power in the denominator, which is x squared. I don't worry about the 2 that's in front of the x squared. I just divide everything by x squared. When I divide x to the 4th by x squared, it's x squared plus 1 over x squared. That's a little 2, sorry. My penmanship's not very good. Squared over 2 minus 3 over x squared. Now as I send this to negative infinity, what I'm going to get is, on top is negative infinity squared plus 0 over 2 minus 0. When I square out the negative infinity, it's going to become positive infinity over 2, which is just positive infinity. Got to be a little bit careful about that one because we're squaring out that positive infinity. We're squaring out the negative infinity, and that's why it ends up at positive infinity and not negative infinity. Our third example is when the power of the denominator and the power of the numerator are equal to each other. And when I have the limit as x approaches infinity of 5x squared minus 3 over 2 minus 3x squared, I'm going to divide everything by x squared. And the reason I divide by x squared is because that's the highest power in my denominator. So I'm going to get 5 minus 3 over x squared over 2 over x squared minus 3. Now as x goes to infinity, I'm going to get 5 minus 0 over 0 minus 3, or negative 5/3. This is a very common type of problem they like to ask, where if you have the power in the denominator and power in the numerator equal, then that limit's going to end up being the ratio of their leading coefficients. Remember, those leading coefficients are the numbers that are in front of the highest power in both the numerator and denominator. The other types of problems that we might get here is when I have something that has like a vertical asymptote in it, and we get some sided limits. And there's a couple. This gets a little bit confusing. There's a couple different ways you can represent these problems. Let's say that I have a question that I have a graph that's given to you, and let's just let this x be 1. I have a graph that looks something like this. Some sort of rational function graph. And what I can do is I can take a look at when x is approaching 1 from either side. So if I had something like the limit as x approaches 1 from the right of the function f of x, the way I like to write the answer is I would say that goes to infinity. So I'm approaching 1 from values that are greater than 1. So I'm going this way towards 1. And as I go that way towards 1, I grow without bound. If I approach as x approaches 1 from the left-hand side, that means now I'm approaching 1 going the other direction this way. And as I approach 1 going the other direction that way, I'm going to negative infinity. And so then if I asked you something like, what is the limit as x approaches 1 of f of x, since those top two don't go to the same value, I would say this does not exist. In some books and some publications, they'll tell you the first two don't exist as well. That doesn't matter. You can either represent the solution as infinity, negative infinity, or you could say it does not exist. I like to use the infinity and negative infinity because we spend a lot of time in our first semester describing graphs, and that's more descriptive than does not exist. Does not exist does not tell me much about the graph. The last type of question we're going to have in this section are when they describe a graph by giving you limits as x approaches infinity or negative infinity, or x approaches a particular value and it's going to positive infinity or negative infinity. And these all become asymptotes. So the first one, the first two limits as x approaches 1 from the left and from the right, where the graph goes to positive and negative infinity, what that's telling me is that I have a vertical asymptote at 1. So I put in 1 here, I put in my vertical asymptote, and draw that in. Now as x approaches infinity or negative infinity, I have a horizontal asymptote at 2. So the graph goes and approaches at 2. Now I just have to kind of sketch the graph. The graphs are going to be reflections of each other over that point that I just created at 1, 2. And so if I look at, okay, as x approaches 1 from the left-hand side, I'm going to positive infinity, which tells me that this graph looks something like that. I'm going to go to positive infinity as I approach 1 from the left. As I approach 1 from the right, I go to negative infinity. And then as I go to infinity, or as I go to negative infinity, the graph approaches 2, and those become my horizontal asymptotes. These sketching of graphs has become bigger and bigger in our AP Calculus class, and I'm sure you'll get questions where they have limits, or we'll start describing derivatives, that kind of stuff. So you can take a little stab at that. We'll talk about those a little bit more in class, and hopefully clear up any misunderstandings you may have. Good luck.